Yes. Here we go. Again, this is MTS ALG2 4.3. Questions 17 through, I'm going to get 17 through 24. I'll get through on this video. Now, I'm giving you basically everything we need for Chapter 4. There might be a couple more we'll talk about later on, a couple more rules. These are the basic rules. So the first rule is going from exponential form, okay? So this is exponential, and this is logarithmic. Form.
Yeah. What was country?
I don't think there's an A in there. I don't know, maybe there is. I'm confused. Yeah, there is. Didn't look right though. Logarithmic. Logarithmic. Okay, so anyways, so logarithmic form just means that we're using logs. What is a log? A log is an exponent. That's it. It's really simple. Okay? A log is an exponent. These rules are kind of mundane. They're taking our exponential rules and they're putting them into log forms. So let's look at this rule really quick. It's pretty simple. It says log base b of b is equal to 1. Okay? Now if we take that rule and put it in exponential form, log base b of b is equal to 1, and we transfer that into the logarithmic form. Remember, a power is it has a base, right? So a power, right? This is a power. It has a base and it has an exponent. Okay? Then it has a number. Okay? Same thing with the logarithm. It has a base. Okay? It has a number. And a logarithm, if you just remember, a logarithm is an exponent. That's what it is. So it is an exponent. So I can take this base, raise it to the exponent, and what does that equal? B to the 1 equals B. And that's why log base b of b equals 1. What we're saying there is log base 3 of 3 equals 1. Okay? So anytime your base and your number are the same, it's always going to equal 1. Same aspect with this one. Okay? Anything raised to the 0 power is what? 1. Okay? So in essence, you're looking at your base, right? Wait a second, this is backwards. This should be 1 and 0. Because anything raised to the power of 0 is 1. Must have wrote that down. Not dyslexia, it's just yeah. Sorry. Okay, so anything raised to the 0 is 1. So again, if you took it log, really crappy pen. Woo! 1 for what? Log, right? base b, right? It could be anything. Give me a number, anything. Any number you want. 6. Right? Raised to the 0 is going to be 1. In other words, my base 6 to the 0 power equals 1. That's all we're saying here. Okay? Now, because logarithms are exponents, then the exponential rules fit. Remember all your exponential rules. Right? When we multiply powers that have the same base, what do we do to the exponents? We add them, right? B squared times B cubed equals B to the 5th. Right? So, again, when we multiply exponent, powers that have the same exponent, so bases that are the same, right? Powers that have the same base, right? We add the exponents, so therefore we multiply, when we're multiplying their base, their powers, right? So basically if we said b to the, what is this, b to this, so if I said b cubed times b squared, I would say that's b to the 5th, right? So I'm adding their exponents. So the same aspect with logarithms, because they are exponents, when we multiply two things, we can go this way and say we're adding exponents. Or if we're adding two logarithms with the same base, we can just multiply those two numbers on the inside. Okay? We multiply the two numbers, and then they'll be underneath the same base. Okay? In the same aspect, when we subtract, we divide. Okay? So just like when we divide, if I have b cubed over b squared, I get b, right? We subtracted exponents. It's the same thing. We're subtracting the exponents. Oh, this should have a c right here. Sorry about that. So a minus log c, both to the same base. They have to be the same base. It's going to be log a over c. And again, when we take a power of a power, if I take b cubed and I raise that to the second power, that's going to be, I multiply the exponents, right? So I get b to the 6th. Alright, so this, I'm multiplying the exponents. What I'm going to do here is I'm going to take this exponent and I'm going to move it outside. Multiply the logarithm. So I'm going to take that power and I'm going to multiply the logarithm. Because what is a logarithm?
An exponent.
An exponent. So I'm just multiplying the exponent. That's all I'm doing. Okay? So when I'm taking a power of a power of a power, I'm going to multiply the exponent. That's it. It's the same rules that we're used to. Okay? So, with that in mind, let's clean this up a little bit. I have the rules again. Don't need all that. Okay? That there. Okay. All right. I want to write this as a logarithmic form. Okay. So I want to go from exponential to logarithmic. Okay. So what's the base? The base? X. Okay. What's the exponent?
2.5.
Yep. And this is the number, right? So now I've got the log. What's the base?
X.
X. Of the number? 32.
32.
Is equal to
2.5.
the exponent. Good. 2.5. So what I usually teach my students is log of the base of the number is equal to the exponent, and then I rewrite that as the base raised to the exponent is equal to the number. And these go back and forth. So this is logarithmic. Okay, and this is exponential.
That's the answer, right? The log. Is that x 32? Right.
This is the answer, yes.
Right. In the logarithmic form.
Yep. That's all they're asking you to do is write it in logarithmic form. Okay? So, we're going to write it in logarithmic form. Log, what's the base?
6.
6. So we're taking this 6 and we're putting it right there. Okay? What's the number? 216. And what's the exponent? X. Done, son?
No, just the way you explained it sounded intelligent.
Yeah.
No.
Yeah.
It's not hard.
Yes.
No, but this is easy. Seeing
It's
it.
easy. Now, for some reason, students have a hard time with these rules later on. It's not hard. If we add two logarithms, we're going to multiply their numbers. If we subtract two logarithms, we're going to divide their numbers. Okay? It's really easy. We should be able to power through this chapter, I would think, relatively quickly. We'll see though. Okay. We'll write this one as a logarithm, right? Log. What's the base? 1.2. What's the number? 1. And what's the exponent? 0. None. It's easy. As long as we get this down, this part of the logarithm is just pretty simple. Okay? Alright, last one on this board. What's the base? Okay. What's the exponent? Or I'm sorry, what's the number?
0.25.
0.25, and the exponent is? Okay. And we all know that 4 to the negative 1 is 1/4, right? 1/4 is 0.25, right? This is just explaining it in a different way, in a logarithmic way. Okay? How are we doing? Okay. So, let's do these 4. And I might throw in some fun. Some fun.
Like you're lying again.
All right. What's this? Now we're going from log to exponents, right? So I need to know what's the base here. Is 625 or 4 the base? 5.
5, right?
Okay. So we have the base. So that means that's what I'm starting with, 5, right? Okay, what's the exponent? It's 4, yeah. Remember, a logarithm is an exponent. Okay? So it's 4. And then what's the number? So, yeah, the number is 625. So 5 to the 4th power is 625. So it's easy?
Yes.
Cake. Yeah.
They get uglier.
Alright, next one. Tell me. The base.
2.
2. The base is 2. The exponent is?
6.
Okay. And what's the number? X. And this is how we can figure out logs, right? So that would be how much? 64? X would be 64? Yeah. 2 to the 6th. Okay, so then, what's the base?
4.5.
4.5. What's the exponent?
0.
0. What's the number? 1. Alright. Again, what's the base?
And that's beta.
The exponent?
That's same thing.
1. Alright, and pi. All day, every day. It's cake.
Smoke back.